You know that feeling when your favorite app just crashes out of nowhere? Or have you ever wondered why massive tech projects seem to fail so spectacularly and, honestly, so often? Well, it's usually not for a lack of effort. More often than not, the teams building these systems have accidentally walked right into a trap. Today, we're going to look at the notorious traps of software development, those unseen forces that can take perfectly good code and turn it into an absolute nightmare. Okay, let's dive right into this explainer. Today, we're building a sort of rogues gallery narrative. I want you to think of these concepts not just as dry, abstract computer science theory, but as actual monsters or villains that developers encounter out in the wild. We're going on a safari to identify them, understand exactly how they operate, and most importantly, figure out how to avoid getting bitten. We're pulling our field guide directly from Chapter 5, Anti-Patterns of our source material. This is where it all originates. We'll be breaking down the basics, looking at the different classifications, from everyday software development traps to deep architectural flaws and even total project management disasters.
Let's move to Section 1 and see how this builds. What are anti-patterns? Basically, good intentions gone terribly wrong.
To really grasp what an anti-pattern is, we first got to look at its helpful, well-behaved twin, the design pattern. In software design, a design pattern is great. It documents a recurrent solution to a common problem. It's essentially your blueprint for success. But a design pattern becomes an anti-pattern when it ends up causing way more problems than it actually solves. It's basically a genuinely good idea, but applied in a deeply destructive way.
The formal definition here is actually fascinating. An anti-pattern describes a commonly occurring solution to a problem that generates decidedly negative consequences. So why does this even happen? Well, our source tells us it's usually because a developer or manager simply doesn't know any better. Maybe they lack experience with a specific problem, or, and this happens a lot, they take a perfectly good pattern and just force it into the completely wrong context.
All right, on to Section 2, the code monsters. These are the beasts hiding deep within the architecture.
Meet our first monster, the blob. Some folks ominously call this the God class. This happens when one single massive class just monopolizes all the processing, while the surrounding classes do absolutely nothing but hold simple data. Now, at a glance, it might look like modern object-oriented design, but actually, it's really just old-school procedural design wearing a disguise. The source notes this monster is usually created by accident during rushed iterative development. A simple prototype just slowly mutates into this massive, overly complex production system that's way too expensive to load into memory and literally impossible to test. And right next to the blob is its degenerate cousin, functional decomposition, or the no-OO anti-pattern. This is exactly what happens when smart, highly experienced developers who are used to older procedural languages try to write code in a modern, object-oriented language. They come up with these incredibly clever ways to just replicate their old methods. You'll spot this beast when you see classes named as functions, like calculate_interest, with absolutely zero leveraging of modern principles like inheritance. It just completely misses the point of the architecture. Now, what's really interesting about this next concept is that it's arguably the most famous monster of them all, spaghetti code. I mean, it's been around since the very invention of programming. This is a system that contains almost no structure whatsoever. The execution flow just twists and turns unpredictably. It gets so tangled that the original developer won't even understand their own work after a few months away. Ultimately, spaghetti code forces a project to a point of diminishing returns. And by that, I mean it literally becomes more expensive to maintain this tangled mess than to just burn it all down and start over from scratch.
Moving on to Section 3, bad developer habits, the traps of the trait. Say hello to the golden hammer, affectionately known by some as Old Yeller. This happens when a developer, or even a whole team, becomes completely obsessed with a single favorite software concept or vendor product. Because they're super competent with this one tool, they view literally every new problem as best solved with it. Our source material highlights a classic example of this, the banking community's "our database is our architecture" mindset. You know the old saying, when all you have is a golden hammer, every problem looks like a nail. And because of that, alternative, much better suited solutions are completely ignored.
Then we have cut-and-paste programming, or clipboard coding. Look, we've all done it, but as an anti-pattern, it is a total nightmare. Less experienced programmers might think they're taking a brilliant shortcut by cloning code from the more experienced devs. But here is the trap. When you copy the code, you are also copying the defects. The exact same bug reoccurs all across the system.
Plus, it deceptively inflates your lines of code metrics. Sure, that might look amazing on a performance review today, but it creates an explosive long-term maintenance cost for tomorrow.
Section 4. The testing minefield. Do you believe in magic?
And this brilliantly illustrates a scenario called walking through a minefield. This occurs when software is just pushed out the door way before it's actually ready, resulting in products being released in this sort of perpetual beta state. Driven by this frantic rush for speed over quality, companies launch components that are still riddled with residual bugs. And the result? The end users are unwittingly turned into the bug testers, living in constant fear of a catastrophic system failure right at the exact moment they need the software the most.
So how do we actually diffuse this minefield? Well, the explainer source outlines a really clear refactoring solution. Step 1 is a proper, serious investment in software testing to ensure systems are relatively bug-free. Get this, in highly progressive companies, the size of the testing staff can actually exceed the programming staff. Step 2 requires implementing strict configuration control of your test cases, which finally gives quality assurance the respect and structure it rightfully deserves.
Section 5. Management misfires. Yup, the monster's at the top.
Listen to this absolute shocker of a phrase. Keep your developers in the dark and feed them fertilizer. Wow, that defines what we call mushroom management. It's a toxic environment of total uncertainty, where there's an explicit policy to isolate the system developers from the actual end users. Requirements are just passed secondhand through intermediaries. Without any real user participation, developers have to just make blind assumptions. And the ultimate, devastating risk here? You spend an absolute fortune, and you end up building the entirely wrong system.
So the crucial point here is our final management misfire, the boat anchor. This is a wildly costly piece of software or hardware that serves absolutely no useful purpose on the project. How does that even happen? Well, usually it's through VIP marketing targeted directly at senior decision makers like CEOs who just buy a product without any proper technical evaluation. The developers then waste hundreds of hours trying to magically make it work, they finally abandon it, and this incredibly expensive acquisition is left to just gather dust in a corner somewhere.
Well, we've traversed the minefield, haven't we? We've seen the blob, the golden hammer, and the dreaded boat anchor. Which brings us to one final, absolutely vital question as we wrap up this explainer. I want you to look closely at your own projects right now. Are you genuinely building software? Or are you just feeding the monsters? Identifying these anti-patterns is the critical first step. The next is learning how to refactor them. Until next time, keep your code clean and keep your architecture monster-free.